This form easily tells us our vertex because it tells us how many units left or right we're going to go and how many units up or down. So this first one, actually, we're going to skip the first one. We're just going to go to part B. This graph, the +6, tells us that the graph is going to move left 6, and the -2 tells us the graph is going to move down 2. So that's the stuff that we practiced yesterday. Our vertex is originally at 0, 0. If we were to graph part A, normal y equals x squared, the vertex is at 0, 0. That vertex is going to move left 6 and down 2. So here's the new location of the vertex. So our vertex is located at -6, -2. And you might notice it's the opposite of the number in the parentheses and then the exact number after the parentheses. Directly through this vertex, there is a symmetry line. Parabolas are symmetrical. You could fold it along that vertex and create both pieces overlaying each other. So that's called the axis of symmetry. And it is the vertical line that matches the vertex. So this vertical line matches the x value of that vertex. All right, so if we're trying to graph this parabola, right now we just have one point. We need another point or two so that we can graph the parabola. I'm going to pick an x value that is close to this symmetry line. So this symmetry line is at -6. I'm going to pick -5 and -4. So I'm going to pick this x value -5 and this x value -4. 1 or 2 units away from that symmetry line. And we're going to plug those in. And we can use the calculator to plug them in. We've got -5 plus 6 in parentheses squared minus 2. See what the calculator tells us for that. Then -4 plus 6 squared minus 2. You can either do this in your head or calculator. This first one, 1 squared, 1 minus 2 is -1. This is 2, 2 squared is 4, 4 minus 2 is 2. And that gives us 2 more points that we can graph. So now we have the point -5, -1, and -4, 2. How many of you are looking at this and thinking, all right, that still doesn't look like a parabola, but we have a symmetry line. So this first point, -5, -1, we can reflect that over the symmetry line and put a corresponding point on the left side. -4, 2 is 2 units away from the symmetry line. Go 2 units to the left, and there's the reflected point. So here is our pretty parabola. It's pretty, isn't it? I'm being serious, but I think everyone thinks I'm being sarcastic. Then we need to talk about the domain and the range. The domain is always all real numbers. And instead of having to write out all real numbers, you can just write the word all and then a capital R with a double stem. A capital R with a double vertical stem is a symbol that means real numbers. Quite frankly, if you just write the capital R with the double stem, if you just write real numbers, that's fine. Your domain is always going to be all real numbers. You can plug any real number into the x values of this function. The range, however, is going to be a little bit different. Your range is usually y is greater than or equal to 0. If the parabola has a vertex at 0, 0, the range is y is greater than or equal to 0. But this moved down 2, so our range is y is greater than or equal to -2. This number is always going to be the y value of the vertex. We shifted the whole graph down 2, so the domain shifts down 2. I probably shouldn't have skipped example A. Here's example A. The vertex is at 0, 0. And then we've got the point 1, 1 and 2, 4. And those are all reflected over. The domain is all real numbers. And the range is y is greater than or equal to 0. Every single point on this graph has a y value that is either 0 or larger than 0. And this is the y value of the vertex, because this vertex is the point 0, 0. Okay, really, when you get to your assignment, this is going to be very, very similar to yesterday. If you know how the parabola moves, you can probably pick out which of the 4 graphs is the correct graph for the equation. Do you want to do one? We need to do 2 more. We need to do 2 more. Okay, this one. First thing that you need to do is identify the vertex. This is vertex form, so we need to identify the vertex. Anyone want to take a guess what the vertex is? -2, -7. I was about to give you a helper. It helps if you think about how this movement happens. This is left 2 and down 7. So left 2, down 7. There is our vertex. That means that your symmetry line is x equals -2. So vertically through that vertex, there is a symmetry line. Now, do you have to put that symmetry line on your graph? No. But it can be helpful when you're trying to graph if you have that visually there to help you. Okay, that's all the easy stuff. Now we have to think about getting more points. You want to pick x values that are close to that symmetry line. So our symmetry line is -2. We would want to pick -1 and 0. I usually pick the 2 points, the 2 x values closest to the symmetry line on the right side of the symmetry line. And we plug those in. So 3 times -1 plus 2 squared minus 7. You can do that math in your head, or you can punch it into your calculator. I believe that's -4. And then plug in 0. Zero plus 2 is 2. 2 squared is 4. 4 times 3 is 12. And 12 minus 7 is 5. So I've got the points -1, -4, and 0, 5. Does that parabola so far look like it's going to be super skinny? Does it make sense that it's going to be super skinny? It's got a 3 on the front, so yes, that makes sense to us. We need to reflect those points over. So the point -1, -4 is 1 unit away from the symmetry line. Go 1 unit to the left. The point 0, 5 is 2 units, so go 2 units to the left. And then we can draw in our parabola. Okay, now, honestly, on your assignment, this part you probably won't have to do. You probably will be able to figure out the vertex, and then you'll look at what the stretch or shrink is to decide if it's supposed to be narrower or wider, and you will be able to pick out the graph from that. So you won't have to do all of this when you're doing your assignment. I just wanted to show you that if you had to do this on paper, these are the steps that you would follow. We do need to talk about domain and range. They don't stress this in your assignment, but it will be part of your test, so I want to make sure we practice it. What's the domain? All real numbers. And the range? Perfect. Y is greater than or equal to -7. -7 is the Y value of the vertex. And tomorrow we're going to start talking about minimums and maximums, so I might as well start bringing that up now. If your vertex is the lowest point on the graph, it's called a minimum value, and that Y value of the vertex is your minimum value. Okay, there's one more that I want to try. I'm going to write it in on this blank. F of x equals -2 times the quantity x minus 3 squared plus 5. Okay, first of all, our vertex. The -3 moves us right 3, so that'd be a +3 for the vertex. The +5 moves up 5, so 5. 3, 5. And there's a symmetry line at x equals 3. What two x values should I pick to plug in? Our symmetry line is at 3, so I would pick 4 and 5. I pick the two x values that are closest to the symmetry line on the right side of the symmetry line. That's what I always do. If you want to pick the values on the left side, that's totally fine. You'll honestly get the same thing. And I'm going to use my calculator for this because I just think that that's easier. And hey, I have it right here. So -2 parentheses 4 minus 3, close my parentheses, squared plus 5, 3. And then I plug in 5. -3. So 4, 3, and 5, -3. Reflect those points over. This graph is flipped. And after all we did yesterday, that shouldn't surprise you. There's a negative in front, so it makes sense that it opens down. Your domain is still all real numbers, but the graph flipping is going to affect the range. So the range is going to be y something 5, because 5 is that x value or the y value of the vertex. But because the graph flipped, all of these points are 5 or smaller, so its y is less than or equal to. Because the graph flipped, the range flips as well. It's still going to be the y value of the vertex, but if the graph opens down, it's less than or equal to. If the graph opens up, it's greater than or equal to.